The Khula Bols of Tabla, Analysis and Synthesis. Two distinct sounds emanated from tabla are explored in this work.
ta, ta, tun, tun,
In tabla literature, these two sounds are categorized as khula bols or open sounds. While playing the ta bol, the tabla player damps the fundamental mode of vibration with ring finger, whereas in tun bol, the fundamental mode of vibration is not damped. The results obtained from the analysis of tabol are as follows. Initially, tabol played by the first tabla player is analyzed, and later the results obtained from 10 different tabla players are summarized. The pressure pulse of the tabol played by the first tabla player is as shown. Taking a 50 of it shows that the first peak is relatively small as the fundamental mode of vibration is damped while exciting the tabol. The second peak is the sharpest and the third peak is the highest. Spectrogram of tabol obtained from the STFT analysis also shows that the fundamental harmonic is considerably damped, whereas the next three harmonics sustain for almost the entire duration of the tabol. The decay of STFT coefficients, as shown here, reveals the decay of the sinusoidal partials corresponding to the peaks observed in the frequency spectrum. Averages across 10 different tabla players are summarized. The first 7 peak frequencies observed in the spectrum are tabulated. The next row shows the mean of peak frequency taken across 10 tabla players. The ratio of frequencies is obtained by normalizing with the second mean peak frequency. This ratio shows that the tabol is nearly harmonic. However, the harmonicity is hampered towards the seventh peak. The coefficient of variation of peak frequencies, denoted as %SD, is the highest for the first peak. This indicates that different tabla players apply varied pressure with their ring fingers for damping the fundamental mode of vibration. The mean of normalized amplitudes observed in the FFT spectrum shows that the third peak is the highest. Mean of Q factor shows that the second peak is the sharpest. This trend can be seen from the FFT of tabol played by the first tablis. T40 is obtained from the decay of the STFT coefficients. T40 captures the time taken by a particular partial to decay to 40 dB below its maximum value. Mean of T40 shows that the partial corresponding to the second peak takes relatively longer time to decay. This trend can be verified from the decay curve of the first tabla player. Here the partial at 471 Hz, orange in color, takes relatively longer time to decay. Taking the FFT of the tun bol played by the first tabla player shows that the first peak is the highest. This is expected as there is no damping of the fundamental mode of vibration while exciting the tun bol. Spectrogram of tun bol obtained from the STFT analysis shows that the fundamental harmonic sustains throughout the entire duration of the bol. The decay of STFT coefficients reveals closely similar decay curves for the first and second partial, that is the blue and orange curve. Now let's consider the average across 10 different tabla players. The ratio of peak frequencies shows that the tun bol is also nearly harmonic. The coefficient of variation of peak frequencies is almost similar for 7 peaks. The mean of normalized amplitudes shows that the first peak is the highest. Mean of Q factor shows that the second peak is the sharpest. However, it has relatively smaller peak amplitudes. This trend can be confirmed from the FFT of bowl played by the first tablas. Mean of T40 shows that the second partial takes relatively longer time to decay. This trend is reflected in the decay curve of the first tabla player, the orange curve. Two important observations. First, Q factor and T40 values are mutually dependent. Such dependence enables one to look for the sharpness of peaks in the FFT plot and predict the relative decay of the partials without even computing the short-time Fourier transform. The second observation is that irrespective of Ta or Tun bowls, the highest value of T40 and Q factor is observed for the second partial. This implies that two parameters are not so much dependent on the excitation mechanism. Rather, they depend on other factors such as geometry, material properties, and boundary conditions of the memory. Now we shift to the synthesis of tabol. The pressure pulse of the tabol played by the first tabla player and the synthesized version of the tabol are as shown. Let's listen to the original and the synthesized tabols consecutively. Once more. Synthesis algorithm. Initially, the decay of STFT coefficients in Pascal is averaged across 10 tabla players to obtain a figure as shown. Here the curve of the second peak dominates. To these decay curves, curve fitting is done using two exponential functions. These curve fitting provided the decay function di of t made up of ABCD coefficients for 7 peaks as shown in the table. Next, additive synthesis is implemented by taking the product of the decay function and the corresponding sinusoidal partial. This yielded the synthesized tabol y of t. Our synthesis algorithm converts the tabol played by 10 different tabla players on a particular tabla into ABCD coefficients as shown. These coefficients and frequency ratios of harmonics are just sufficient to synthesize a decent tabol. Which musical interval is heard when ta and tun bowls are played consecutively? Let's listen to them. If we try to hum it, a musically trained ear should be able to decipher a major second interval. Let's try to arrive at it using our data. The decay curve of ta bowl played by the first tabla player when plotted in pascals shows that the second partial at 471 Hz is dominating in the ta bowl. This corresponds to an A4 sharp musical note, whereas similar curve of tun bowl shows that the first partial at 259 Hz is dominating. This corresponds to C4 musical note. Ta bowl gave the A4 sharp note, and tun bowl gave the C4 note. Since musical notes that are an octave apart are perceived to be similar, C4 and C5 are perceived to be similar. Now an interval inversion is done, where C4 note in the descending interval A4 sharp to C4 is moved up by an octave, resulting in an ascending interval A4 sharp to C5 as shown here. This interval can be transposed to a lower octave and obtain the interval A3 sharp to C4 as shown here. Pitch perception strongly correlates with the fundamental harmonic of a sound signal. So when tar bowl is excited, and since its fundamental mode of vibration is damped with a ring finger, it seems that a non-existing fundamental is conjured up while listening to the tar bowl. Such a missing fundamental illusion plays a role especially while discerning the interval being heard by playing ta and tun consecutively. Thus, when played consecutively, ta and tun creates a major second interval, A3 sharp to C4. To conclude, we developed a method to synthesize ta bowl, and this method can also synthesize other Khula bowls. We proved that T40 and Q factor are not much dependent on the excitation mechanism. Also, we observed that even without finding the STFT, the decay of partials can be predicted just by looking at the sharpness of peaks in the FFT spectrum. In future, synthesis of all Khula bowls and their listening tests are to be conducted. These were the references. Questions and suggestions are most welcome. Wishing you a wonderful day.